Today we're looking at searching algorithms. So an algorithm is just a set of rules that can be followed to achieve a task. So when we're using searching algorithms, we're thinking of a set of rules that we can follow so that we can search for a particular piece of data. Now this piece of data could be in some sort of list or array, and it might be good for looking up to see if something already exists in a database or in some sort of data set. Now for your exam, you're going to need to know two main searching algorithms, which is the binary search and the linear search. Now for the binary search, we have to be able to perform it and show the steps of it, whereas the linear search, we more just need to be able to talk about and just explain how the steps would work. So let's start with the binary search. Now one of the most important things we need to remember about a binary search is it has something called a prerequisite. This is something that has to have happened before a binary search can take place. So the prerequisite of a binary search is the data has to be sorted first. At each step, it will halve the amount of data that it's got left until it finds what it's looking for. So this is really good for large data sets. A disadvantage is what I've previously mentioned, the fact that the data has to be sorted first before it can take place. But if you've got a really large data set, then it's going to still work out time-wise a lot faster. Another disadvantage would be it's more complex to actually code. So for beginners, it's not going to be an easy job. Let's look at the steps to perform a binary search then. So this is a typical kind of question you might get in your exam. A list of sorted numbers are stored in an array. Show how a binary search would find the number 18. So the very first step we would do is to find the midpoint. You would have a zero-based system. In the actual first position, that is actually position 0. Then 1, 2, 3, 4, 5, 6, and 7. Now we need to be able to find our midpoint, and we're going to use a tiny bit of maths to find this point. If you made it clear that you understood that you needed to find the midpoint first, then you didn't need to use the math. So you could just literally write find the midpoint or put a little arrow pointing to the middle point. But if you were going to find the midpoint, we would do the very left side, which is 0, added to the very right side to begin with, which gives us 7. Now we've used a word here which is div, and we're going to div 2. Now this does mean divide, but because we're using div, it's going to return the whole number only. So in this case, 7 div 2 would give us 3.5, but we're going to ignore the 0.5 because it only returns the whole number. So we found our middle position, which is going to be 3. Now it's a good idea on your exam to actually show what you're doing throughout the steps. So you can actually remove data, put lines through it, put arrows. It's really helpful for the examiner to show your understanding. So in position 3, we are storing the integer 12. Now we know because we sorted this data that it must be greater than that. So at this point we can discard the entire left side, including position 3, because we've already checked there. So all I'm going to do is put a line through it and cross that out, and we're left with this data. Then all you've got to do is repeat the steps until you find what it is that you're looking for. So our new very left position is position 4, added to our very right position, which is position 7. Div 2 is going to give us 5. We know now that it's going to be less than what's in position 5, which was 21. So we're going to discard that whole side on the right, including position 5. At this point, we've only got position 4. That is both our left and right side now. So 4 add 4 gives us 8. Div 2 is going to give us 4. So finally, we are pointing at the position where we wanted to find our data. So you could just write 18 has been found. The next searching algorithm that we're going to look at is a linear search. Now a linear search will start at the very first position and it will just move along one position at a time until it finds what it's looking for, or it reaches the end without finding it. Now the biggest advantage of this is that the data does not need to be sorted first, and it's much easier to program, so it's quite simple to understand. But as a disadvantage, it's much slower on larger lists. So compared to the binary search, which got rid of half the data each time, let's say that the data that you're looking for is right at the end, it's going to take a lot longer to find that piece of data that it's looking for. So for this one, like I said, we don't usually have to show the steps for a linear search, so we just need to be able to explain it instead. So let's look at a practice question together. Explain why a linear search would be more suitable than a binary search when using an unsorted list. So it's only a 2-mark answer, and what you could write is a linear search does not require the list to be sorted. A binary search only works on sorted data, so cannot be used without first sorting. So we've got a question for you to practice using the binary search. A list of sorted numbers is stored in an array. Show how a binary search would find the number 7. Okay, let's go through the answers then. So like before, we need to start by finding our midpoints. We can do this by doing 0, add 8, which is our very left position, added to our very right position. Div 2 is going to give us 4. So 0, 1, 2, 3, and 4. So this is our current midpoint here. Now we know because the data's been sorted that it must be less than that because we are looking for the number 7. So we are going to discard the entire right side, including position 4. Then we're going to use our new left side added to our right side, which is 0 plus 3. Div 2 is going to give us 1. So we are now looking at position 1 and we have found our data. So 7 has been found. That's the end of the question. And that's it for this one. I'll see you next time.